Interference. In this video, we will discuss about the term interference. Interference means the superposition of two or more waves such that the intensity of a resultant wave get modified or changed, or the energy get redistributed. For example, जब आप रेडियो स्टेशन सुनते हो, you are listening the radio stations at particular point of time or at different times, you will find that at same station you will hear the two voices of two singers, two radio stations, and you will not able to interpret any one of it. So this phenomena of superposition, एक स्टेशन का वेव दूसरे स्टेशन की वेव आपस में सुपर इम्पोज कर रही है, जिससे कि उसकी इंटेंसिटी क्या हो जाती है, मॉडिफाइड हो जाती है, एंड whatever you will listen, that is a mixture of both the stations. This phenomena of superposition is known as interference. Now let us discuss about the phenomena of interference in terms of light. As we know that when the two waves reaches to the point and these two or more waves interfere each other such that the intensity get modified. For example, suppose I am having two sources. This is your S1 source and this is your S2 source. This S2 source also gives out a light. This is your S1 source also gives S1 source gives out a light, and S2 source also gives out a light, and this light reaches to this point O. Now here at this point of O, these two lights interfere each other, superimpose on each other, such that the intensity get modified. I suppose the intensity get modified and in such a way that intensity becomes maximum, or it get modified in the positive sense and such that the intensity becomes maximum. If the intensity is maximum, that point is bright point, and that will be your bright. This O point will be brighter one. When the intensity becomes maximum, then this type of interference is known as constructive interference. In the constructive interference, the intensity becomes maximum. How this intensity becomes maximum? As we know that, suppose I am having the two waves, having amplitude, the first one wave that is represented by the hard line, and it is represented by the hard line, and having amplitude A, and the other one wave is represented by this dotted line having an amplitude B. So when the two waves superimpose on each other or falls on one another in such a way, when the crust of one falls on the crust of other, or trough of one falls on the trough of other, then there is a constructive interference and the intensity becomes maximum. As because of the principle of superposition, the intensity of a resultant wave or amplitude, according to the principle of superposition, the intensity of a resultant wave, according to the principle of superposition, the resultant amplitude of this wave is given by the vector sum of their amplitude. So here the amplitude of a wave is A and amplitude of second wave is B. Both are in same direction, so resultant wave will be having amplitude A plus B. So this amplitude, if I draw the wave, the resultant wave is given by like this one, and it is having an amplitude is equal to A plus B. So this is the amplitude of a resultant wave, and it is your maximum amplitude. So here we can say that, as we know that the intensity is directly proportional to the scale of amplitude. So if the resultant wave is having an amplitude A plus B, then its intensity becomes or is proportional to A plus B cos square. So this is your constructive interference. Now let us talk about the destructive interference. So suppose here also when the two waves coming or two lights coming from the or two ray of lights coming from the different sources reaches to this point O and the intensity get modified in such a way here the intensity becomes minimum, सबसे कम हो जाती है, and it is minimum means it is a darkness, it is a point of darkness. So here when the two waves superimpose in such a way that the intensity becomes minimum, and that type of interference is known as destructive interference. So here the intensity is minimum. So how can you say that what is the position of crust and trough when the two waves interfere destructively? So I have drawn this diagram here. I am having this is your first mode wave. It is having an amplitude A, and this is your second dotted line represent the second mode wave having amplitude B, and the resultant wave which is formed here according to the principle of superposition, the resultant amplitude is a vector sum of amplitude. So here this amplitude represents in upward direction and this here amplitude is in downward direction. The resultant amplitude will be equal to how much? Vector sum, that is A minus B. So here this will be your wave, resultant wave. So this is your resultant wave and it is having an amplitude is equal to A minus B. So similarly, when the two waves superimpose on each other in such a way that crust of one falls on the trough of other, or crust of other falls on the trough of one, then there is a destructive interference or darkness. So if you want to so we know that the amplitude of resultant wave is A minus B, then the intensity will be, the minimum intensity will be given by A minus B cos square. It is in fact proportional to. So intensity is proportional to A minus B cos square. So this is your constructive interference and destructive interference. Furthermore, if you calculate the ratio of maximum and minimum intensity, you will find here the maximum intensity is proportional to the sum of the amplitude and square. Similarly, the minimum amplitude is equal to difference of their amplitudes cos square. Now if you calculate the ratio of both, so the maximum intensity divided by minimum intensity. So it is coming out to be, since proportionality is there, so if you remove this proportionality constant by introducing a constant, that constant is K. Here also you can remove by introducing a constant, that is K. If you put both the value, you will find that the ratio of maximum and minimum intensities. So K get cancelled out, you are left with only A plus B divided by A minus B the whole square. So this is your maximum and minimum intensity. Similarly, you can also calculate the ratio of their amplitude. For example, suppose this is your I maximum and this is your I minimum divided by I minimum. If you rate A plus B, A minus B का whole square. If you take the square root, so after solving a little bit, you will find that I maximum plus I minimum, I maximum minus I minimum. Same operation you can do for the right hand side also. So it is A plus B plus A minus B divided by A plus B minus A minus B. It becomes plus B. So after solving it a little bit, what you will find? Here B get cancelled out, A get cancelled out. It is 2A divided by 2B. So it is nothing but it is A divided by B. So what you go out from here? So you get the ratio of your amplitude is equal to the square root of maximum plus I minimum square root, I maximum square root plus I minimum square root divided by I maximum square root minus I minimum square root. So this is your two relations we have calculated. First, in the term of ratio of their maximum intensity and minimum intensity, and ratio of their amplitude of individual waves in terms of maximum and minimum intensity.